Welcome back, and today I'm going to show you guys another environment I made from the Braitenberg vehicles experiment. Real quick, let's just go ahead and talk about the background for this experiment. There was this famous neuroscientist and cyberneticist. His name was Valentino Braitenberg. He works at the Max Planck Institute for Biological Cybernetics in Germany. This guy, born in 1926, so probably in the late 1950s, developed these things called Braitenberg vehicles. And these are just very simple little engineered devices that have two wheels typically and two sensors. So what Braitenberg found out was that if you organize these sensors in different ways, you can come up with complex behavior from simple organization. And so this is what we really like to hear in complex systems, that there's simple rules that develop into complex organizational patterns. So in the original Braitenberg vehicles, there are 4 different vehicles with different sensor configurations. The 2 that are the most prominent that we're going to talk about today, he named fear and love. So you can get a behavior that looks like a fear response if you wire the light sensors to the wheel motors in such a way that forces it to move away from light. You can also get a behavior that looks like love if you do the opposite wiring and you make sure the wires enforce a behavior that will get it to move towards the light. So in this experiment, I didn't hard code the connection between the light sensors and the motors. Instead, what I wanted to see was if reinforcement learning could learn the hard wiring itself based on a simple reward scheme. Just go ahead and show you guys what it looks like to have these little vehicles. There's this very wonderful site someone has put together that does a very simple simulation of the Braitenberg hardwired approach. And you can play around with this if you go to this website. So if we take a look at this very simple diagram here, it's a very lovely diagram, we can see here that we've wired the left light sensor to the left wheel motor, and likewise we have wired the right light sensor to the right wheel motor. Okay, so that's important because as we start to go towards a light obstacle in this hard wiring, that will cause, if this sees the light, that'll cause this one to activate this motor, and we will in fact turn away from the light. Okay, so if we go ahead and we look at the love paradigm over here, so what we're doing here is the same thing, but instead we're going to slow the motor. So if we look at them, and what we have said here is that when we connect the leftmost sensors to the leftmost wheel and the rightmost sensor to the rightmost wheel, we will speed towards the sensor when it comes into contact with light, and that means that we'll veer in the direction and we'll get a behavior that looks like fear. And the same thing is going to happen with love, except for instead of veering away, we're going to slow down, and that'll end up making us go closer to the light until it reaches a perfect distance. All right, so let's take a look at the Unity environment. So I have this car vehicle here. All right, I have 4 wheels instead of 2 because I found it easier to do the setup with 4. But it is rear wheel drive, so it's basically the same as having 2 wheels. What you're seeing on top of here, this little green egg looking thing, I have just placed a light on top of this vehicle because I'm working in a plane that doesn't have a sun. So if we take a look at this environment, it is just a giant plane for this vehicle to move around on, and I have no sun in the picture. So that means that the light sensors are only going to pick up on the street lamps that get initiated when we start the environment. So if I switch the display, we can see there is some randomly placed street lamps that have volumetric lighting, which means that depending on where this vehicle goes, how close it gets, the vehicle will be able to detect the light from the street lamps. So how does the vehicle detect the light? If we zoom in on this guy, we can see that I have attached two cameras. And you're thinking, well, why are you using cameras and not raycast? Because originally the Braitenberg vehicles are done with light detections, and these cameras are 1 pixel by 1 pixel. So we are literally seeing 1 pixel of light. This ends up being a light sensor for the left and the right. And if we look very carefully on this vehicle, I've set a little ball here, so that tells us the head of the vehicle. So when we are in the game mode, we're watching the car move around. So here I'm controlling the car with my keyboard, and I'm turning, right? So as we do this, I can tell we're going backwards, see, because the egg is let me zoom in a little bit. You can see this is the head. So this would mean that I'm going backwards, and now I'm going forwards. And when I run into a light post, if I am in the love mode, then I get a small reward, and that light post disappears. Otherwise, we would keep moving around in circles and just stay in that spot collecting reward forever. So we had to make sure that the light posts disappear. So let's take a quick look at how we set up our agent. So this car root, that is my agent. And I've attached a rigid body on this thing. And there is a suspension script that came with the vehicle prefab that I used that also has this vehicle script. The vehicle script is what is actually running my ML-Agents commands. We'll take a look at that in a minute. But you can see here that I have specified my left and right wheels, which are going to be my rear wheels. I have a lamp prefab that's going to get instantiated on when the episode begins. And I have a type. So if we set the type to fear, then the reinforcement learning algorithm has to learn to avoid the lamppost. And if we set it to love, it has to learn to go towards the lamppost. All right, and then we have our standard behavior parameters. I have a behavior named drive. So we have continuous actions, and we can turn left, right, or stop. And I've been training the model, so it's set to default. And I have a decision requester that's going to request decision of actions to be taken. And I also have my two camera sensors. I had to put two on here because I have a left light sensor and I have a right light sensor. Okay, so one more thing, but before we take a look at the code, I want to go ahead and show you guys what my lamp prefab looks like. So this is my lamp prefab. Let's go ahead and open that up. I have two volumetric lightings that emit from this lamp sector here, 1, 2, and that creates this wonderful light effect that will change the pixel brightness as the vehicle gets closer to it. And what I've done is I've gone ahead and I have put on this lamp post, I've gone ahead and put a box collider, and I have tagged this lamp, this prefab, with the lamp tag, and I've set the box collider as a trigger. That's important so I know when I run into this object, I can use on trigger enter instead of having to search all the time whether or not I've run into a lamppost. So let's go ahead and take a look at that code. Okay, so I have my standard Unity project going on here. I'm using ML-Agents. In this project, I'm using version 1.7. So what I've done is I have set up a class which is going to be called vehicle, which is the name of the script, that is going to inherit the agent from the ML-Agents package. I need the rigid body that is on my vehicle. I'm going to have an audio source so I can listen to my training. This is for the wheels to operate, and again, more wheel stuff, a ton of wheel related vehicle driving stuff. I have my lamp prefab, and I'm going to have a list that I'm going to put all of my lamps in so I can keep track of what lamps have or have not been deleted. Okay, then I need to know the type. Is it the fear or love that we're trying to learn with the reinforcement learning algorithm? I need to know how many lamps I want to instantiate. So when we start the environment, we are going to go ahead and get the rigid body component off our vehicle, and we're going to get the audio source. We are also going to figure out our wheel collider, which is another script that is pre-built from the prefab that I used. Alright, so here we're just going to go ahead and do all this stuff that has to do with creating the car, the vehicle itself. And when the episode begins, if I have any lamps that weren't run into or eaten by our vehicle, so to speak, then go ahead and delete them so I can start fresh. And now I actually want to do the starting fresh, and I want to create all of those lamps. So I'm going to instantiate all my lamp prefabs in some random place so our vehicle can learn spatial invariance. So that's what we're doing here, and then I'm going to keep track of them in this instance as lists. So the last thing I need to do when we start the episode is to place our Braitenberg vehicle in the place in a random location. We want to make this to be able to generalize to new test, so that's what we've done here. And then we're also going to choose a random rotation in the X and Z plane, or in the so we also want to choose a random rotation in the Y dimension. That's which direction are we facing, looking at as the vehicle, and so we're going to do that and zero the velocity so we're not sliding all around as soon as we walk in. Okay, so the observations we're going to take are just the two left and right camera sensors, which automatically get added to the observations because we place the camera sensor components on our agent. That's all taken care of, super easy, and we can move on to on action received. So what's going to happen is we're going to get a small negative reward just for existing to make sure that we enforce the vehicle to move around and to try different policies instead of staying in one place. So adding a negative small reward, it helps enforce that in your reinforcement learning algorithm protocols. And then what we're going to do is we're going to create a control signal and we're going to normalize it, and this is what the reinforcement learning algorithm is going to change in order to figure out how to control our vehicle. We are then going to take that control signal and interpret that and apply that with the regular Unity programming to move the vehicle around. So I had to do some coding here that says if we are type love, then our behavior is going to be going to the lamps, and if we're type fear, then we're going from or away from the lamps. So I have this drive algorithm, which is going to take our control signal and do the driving. And if we fall off of the platform, then we are going to set our reward to -1 because we shouldn't fall off, and we're going to end the episode. All right. So on trigger enter is a very useful tip. You've probably heard about this in my other videos if you've been following along with me. So what happens is if our game object, if our vehicle runs into any other game object, then we're going to compare the tags, and if the tag is lamp, if the other game object that we ran into, if that tag is lamp, and if our behavior is set to 2, then we're going to add a small positive reward. I'm going to print target acquired, and I'm going to destroy the lamp game object and play the learning sound. Okay, so if the behavior is from, let's say we're doing the fear learning, if the behavior is from, we're going to add a small negative reward, and we're going to print bad Braitenberg, because that means that if we're trying to learn the fear, we should be trying to learn aversion, and we've actually run into the lamps, which is the opposite of what we're trying to do. All right, so what we have here, part of the control signal, is if we can do left, right, or brake. So what I've set up here is that we have an angle, we have a torque, which is going to be the X and Z of the control signal, and we have a handbrake. If that's over 0.5, we're going to brake, else we're not going to brake. Okay, and the rest of this code is just some standard stuff to make actually driving the car work that we're not going to get into. And as always, it's really important to have a heuristic so you can test out your stuff before you throw it into the reinforcement learning algorithm. And we have our vertical and horizontal. I didn't bother putting a break on it because this was good enough for me. So that's the code. Briefly, I can just show you guys what my different configuration YAML files look like. So for proximal policy optimization, I had the smallest model possible with the built-in algorithms from ML-Agents for the PPO and for the SAC. I made these super small. They're just one layer, very small amount of hidden units, 32 hidden units here in the PPO and 32 hidden units here in the SAC. And I tested it as always with either memory, extrinsic, curiosity, and combinations of those. So what did we end up with? How did we look like in our results? So if we get over here to our tensor board, we can see I've run a lot of stuff. And if we look at the love algorithm, which means that we wanted our Braitenberg to use reinforcement learning to figure out how to learn the hard wiring for the love behavior. That means the reinforcement learning had to figure out whether we should be making the wheels spin faster or slower in order to have a behavior that looks like our Braitenberg vehicle loves lamps. Alright, so most of these did pretty bad with the exception of the soft actor critic with extrinsic reward. And if we turn those off and we look at the fear algorithms, we can see that most of these did pretty bad too, and they're not all populating in my tensor board for some unknown reason, which we won't get into. But anyways, what I found here that I think the best is also going to be our soft actor critic with extrinsic and maybe with curiosity. So I wasn't super pleased with how I implemented the fear reward because I did not set a small number of max steps, which means that our Braitenberg vehicle can just aimlessly move around for hours on end. And that's what you're seeing now in these training clips. So this is the fear approach, or the fear Braitenberg vehicle. This is how it trained over a long time. It's going really fast because I took hours of this video and sped it up for you. And you can see it's pretty easy for this guy just not to move around a lot. So in the future, we may want to think about penalizing the vehicle for staying in some small radius location, and that would force the vehicle to explore more, which is also why I think the SAC with curiosity may end up being the best algorithm for the fear reward. Alright, so now we're looking at the love vehicle that has had many hours of training as well, that ended up having the SAC with basic extrinsic reward do the best. And what I found was really interesting here, and this is what the Braitenberg vehicle is all about. We have a very simple algorithm, right? A very small one-layer network with 32 units that's saying figure out how to control this guy so that when it runs into a lamp, it gets a small positive reward. And you can see that the vehicle learns to turn in circles. It learns to just kind of a little bit epileptically move around in circles continuously. It's almost like one of those games when you were little, which you would take a crayon and you would draw in circles and it would make all these different circles. And I don't know, I just thought it was really cool that we saw this type of complex behavior emerge from these clips, which is exactly what the Braitenberg vehicle is supposed to show us. So, all right, so just overview again, here we are. We have chosen to have a vehicle which needs to figure out how to control the motors of its wheels in order to have the objective behavior that we have chosen for it. We're going to have a plus 0.5 for correct behavior, and if we are in the love category, and if we are in the fear category, then we are just going to have a negative 0.5 for incorrect behavior. Both different types of vehicles get -1 reward for falling off the platform, and the episode starts over. The best models ended up being the SAC with either extrinsic in the case of the love vehicle or curiosity reward in the case of the fear vehicle. Both different kinds of vehicles had the exact same setup with two light sensors as input. The output or the actions available to the vehicle agents were the wheel angle, wheel torque, and brake. And again, this was rear wheel drive. And the testing that we ended up using was randomly placing the vehicle with various lights and intensities in the scene. So that's what we ended up doing. What we saw was this complex behavior emerging. We saw circle patterns emerge in the case of the love vehicle, and we saw this kind of jittering effect happen in the fear vehicle. So thanks for watching as always, and we're going to have more demos coming up, and I hope to revisit some of these videos in the future with our own learning environments. Thanks for watching, and if you enjoy this content, don't forget to like and subscribe.